Hey, thank you.
Thank you.
Thank you, Adam, and thank you all very much for coming by and hearing what we have to present today. First want to say thank you to ActiveView, one of our, quote, strategic alliances and partners, and what you see represented here at this exhibit is actually a combination of ActiveView, which is a leading command center software, and EnXchange, which is really about a platform, an energy platform, that actually aggregates and integrates data all the way from the generation to the toaster. The subject matter that we really want to just take a few moments to share with you today is one that I think everyone is seeing a lot of here at the conference, and that is what is called a DERM, a Distribution Energy Resource Manager. We're going to speak about that not just in terms of a DERM, but we're also going to speak about it in the context of virtual power plant, as well as energy as a service, and as microgrids. I think a lot of those terms become somewhat synonymous, but one of the things we set out to do nearly a decade ago at EnXchange was to create an agnostic platform that literally could provide a 360-degree view of all the assets from the generation to the toaster. And so I'm going to show you back here on the wall a little bit about our platform, how our platform works, how we really believe that these are major differentiators of what is in the market and what the market is demanding today as we move to a digitized economy and as we move to a more distributed economy. And so I'm going to start out by showing you on this back wall what we really believe is going to be required as a virtual power plant or as a DERM. And that is, first of all, the ability to have a system of systems. In other words, a system that can actually sit on top of, whether that be a SCADA system, a GIS system, an OMS system, or even beyond the meter to building management systems. We wanted to create a system that allowed all that data to come into one platform. And what you're seeing here is that platform for EnXchange. But we also really felt that we needed to really recognize what were some of the key components of building a DERM. First of all, as you can see up here, what we call the component layer. The component layer meaning that we wanted to bring in any component, any intelligent device, whether that be on front of the meter or beyond the meter. Secondly, as you can see, the communication layer. The communication layer being that layer of security on how data gets passed all the way from a grid interactive controller, which you see over here to my left, which has been developed by EnXchange. It is where we have the ability to put this, for example, at a commercial industrial account and collect data from assets on both front of the meter and behind the meter and pass that through a secure environment. Thirdly, the information layer. And what's really important about this information layer is that it's not just the utility that needs the data, it's also the commercial industrial account that needs the data. So our platform is a hybrid platform. It allows both the utility or the microgrid operator or the virtual power plant operator to see the data, but it also allows the C&I customer to see that data at the same time. So we really believe that's kind of the Uberization of assets, or the monetization of data, if you will. Fourthly, we also knew we need to have the functional layer. The functional layer meaning that we needed the ability to do things like transactive energy. In other words, energy as a service. That we could create algorithms, we could create intuitive experiences, and not only have the operator of our platform do that, but also we wanted the ability to actually send that data back to the controller as an algorithm and actually put that on the edge computer. So basically, if this, then that. If prices are at this level, operate the generator, or operate the battery, or shut down the HVAC, those types of things. The last layer is that business layer. In other words, we're all trying to monetize this idea of being a DERM and a virtual power plant. And what we're really excited about our partnership with ActiveView, as you can see on this diagram behind me, it really is the two bookends. It's that ability to structure data, organize data, create a seamless experience with data, but then push it to a wall, a display, to where literally it begins to make logical sense, and we begin to turn data into a story, we begin to turn data into transactive energy. So again, you can kind of see that scenario back here. What I would also point out, as you see these 4 different screens on the outside, what that represents is basically different types of instances or different platforms for different companies. You see back here HWH, a construction company. You see back here WePack, which is a packaging warehouse company. You see back here Rogers Wave, which is a manufacturing company. And they all represent just different companies that have the ability to be a part of this DERM or to be a part of this virtual power plant. Over here to my right, in kind of conclusion, is what you're seeing is the actual platform. And if you look at the menu structure here, you see that we have what is called a network view. That network view basically gives you a nodal graph view of your entire network of assets from generation to the toaster. What we think is so important is we have been so in tune with managing a physical grid. What really this allows you to do is to manage a virtual grid, because we virtualize the grid, the physical grid, through this graph nodal architecture. So Scott Heifer is showing you here, I can type in, for example, the database and say, I want to find an HVAC unit. And when I type in that HVAC unit, in this particular case, I'm seeing every single HVAC unit. If I were a utility, that might be hundreds of thousands of HVAC units. If I clicked on one of those HVAC units, you're going to see it's going to come up and show me the HVAC unit and the sensor connected to it. What's very important, what you're seeing here, is the ability to trace that particular asset both upstream and downstream. Now I have the ability to keep expanding that network and seeing that that actual HVAC is connected to that building's connected to that meter's connected to that transformer's connected to that phase is connected to that feeder's connected to that substation, and that substation's connected to that power source. That's the virtual grid. That's the ability to trace that data and really begin to create that overall experience of a DERM. If I can do those things, Scott's going to click on the DERM application to kind of bring this full circle. And when I click on the DERM application over here to my left, what I'm actually seeing is all the interconnection points. So if Scott clicks on the interconnection points, you're going to see here a list of every interconnection that's in my disposal or in my capability to control. So if you're at a utility and you're really looking at the fact that, hey, we're not building new power plants, we're not building central station power, and I need to access power that my customers are building, solar, battery, generation, whatever it may be, what our system does, it empowers them to work directly with their C&I customers and saying, we want to interconnect with those assets, whether it's solar, whether it's battery, whether it's your HVAC. Now I have the ability to have that in my system. I have it in my system by feeder, I have it in my system by substation, so I can now begin to manage and right size my assets or my capability of assets into my grid. If you go on down to smart contracts, we have the ability to take those assets and actually put a smart contract behind it, an interconnection agreement. And of course, what we think is really the final mile is, if you go to energy as a service, is that ability to actually control that asset, to either control the asset or to create a control scheme that actually sends a control scheme to the grid interactive controller that actually enacts whatever we're trying to do, whether it be demand response, arbitrage energy, or whether it's resiliency or whatever it may be. I hope what you're seeing here today, because this is kind of supposed to be a Reader's Digest version, and I'm terrible at Reader Digest versions, but I hope what you see here is really the effects of having a system that, one, can take data from systems, whatever that system may be, whether that be in the utility system or whether that be beyond the meter, bring that data into one system, have the ability then to give visualization of that data to the user, and then of course the ultimate being able to monetize that data, monetize that asset by basically modulating those assets or those resources collectively together. So again, we hope that you'll take a moment either now or at some point, come by and talk to some of our staff here about the DERM application, our virtual power plant application. We have a number of other of our partners here that I want to just real quickly point out. We've had the opportunity working with MinMax, and we appreciate, Nan, your being here. It's another partner that we're working with. Wesco, another critical partner of EnXchange. Neo4j, which is the graph technology we're using behind the system. But again, to ActiveView, thank you for the time here with you, and we're excited over the next few days to continue to share with folks the great things we're doing together. Thank you so much.